A seminar on boranes and carboranes. Contents are introduction, methods of preparation, bonding and structure in boranes, types of boranes, carboranes, types of carboranes, Wade's rule, applications of borane and carboranes, and conclusion. Introduction. The primary compounds of boron and hydrogen are called boranes. Boranes were first prepared between 1912 and 1936 by Alfred Stock. The molecules of these compounds are electron deficient. The parent member BH3 is called borane. All boranes are diamagnetic and colorless and highly reactive. This is the 3D structure of borane. General formula is BXHY. The number of boron atoms in a compound is indicated with prefixes of Latin such mono, di, tri, etc. The Latin prefixes are used before borane. The number of hydrogen atoms in boranes is written in Arabic numeral. This numeral is enclosed in parentheses. Example: BH3 is called 3, B2H6 is called diborane 6, B5H11 is called pentaborane bracket 11. Then methods of preparation: when magnesium boride reacts with dilute hydrochloric acid, then it gives mixture of boranes, magnesium salt of the acid, and hydrogen. This method is known as Stokes method. And this is the reaction of Stokes method. Another method is when boron trichloride reacts with hydrogen gas at low pressure, the formation of diborane takes place as the result of the reaction. This is the reaction of Avogadro method. Then comes to bonding and structure in boranes. In boranes, four types of bonds are present. First, three-centered hydrogen boron bond. Second, three-centered two-electron boron 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 bond. Third, two-centered two-electron boron hydrogen bond. Fourth, two-centered two-electron boron boron bond. For example, diborane. Diborane is a compound of two atoms of boron, and with these two atoms of boron, six atoms of hydrogen are also present. Two hydrogen bridges are present. Each boron atom is present in sp3 hybridization. That means boron atoms have four hybrid orbitals. This is the structure of diborane, and four hydrogen atoms are present. Two hydrogen bridges are present. This is the two hydrogen bridges are present. The diborane molecule has two types of bonds. First, four terminal, that is two centered two electron boron hydrogen bonds. Second, two bridged, that is three centered two electron boron hydrogen boron bonds. First, four terminal, that is two centered two electron boron hydrogen bonds. Each of these bonds are formed by sharing of two electrons between boron and terminal hydrogen atoms. This is the four terminal hydrogen atoms. It is normal sigma covalent bond. Then second is two breached, that is three-centered two-electron boron hydrogen boron bonds. Each of these bonds is formed by sharing of electrons between two boron and one hydrogen atoms. It is also called as banana bond. This is the banana bond, three-centered two-electron. Banana bond called because it looks like banana shape and two electron of between two boron and one hydrogen atom. So, then types of boranes. Boranes, closed triangulated polyhedra structure. All corners of triangulated polyhedra are occupied. General formula of closure is BnHn plus 2. Example B6H8, B4H6. This is the closure. Second is nidoboranes. Nidoboranes are formed when one corner of the polyhedra is removed. It is nest-like, non-closed structure. General formula of nidoboranes BnHn plus 4. Example B5H9, B2H6. This is the structure of nidoboranes. Arachnoboranes. These boranes are formed when two corners of polyhedra is removed. It is wave-like, non-closed polyhedra structure. This is the structure of arachnoboranes. General formula of arachnoboranes BnHn plus 6. Example B4, H10, B9, H15. This is all about arachnoboranes. Then fourth is hypoboranes. It is hyponet-like structure. These have most open clusters of borane. General formula of hypoborane is BnHn plus 8. These boranes are having complex structures. Example B8H16, B10H18. This is the structure of hypoboranes. Fifth is conjunctoboranes. These boranes formed by linking of two or more other types of boranes. These structures are very complex and general formula is BnHn plus 10. This is the all about of types of boranes. Then comes to carboranes. Carboranes are mixed hydrides of boron and carbon in which carbon and boron atoms occupy the vertices of triangulated polyhedron. Carboranes are most important heteroboranes. Carboranes are members of a class of organometallic compounds containing carbon, boron, and hydrogen. General formula of carborane is C2BnHn plus m, where m is an integer. Boranes and carboranes have same number of electrons in their bonding framework, will have similar structure. This is the introduction of carboranes. Then types of carboranes. First, chlorocarbonanes. This is the structure of chlorocarbonanes. It is closed cage structural arrangement of the carbon and boron atoms, where all boron and carbon atoms occupy all vertices of the polyhedron. General formula is C2BnHn plus 2. Example C2B8H10. Next, nidocarbonanes. One corner of triangulated polyhedra is removed. Its structure is nest-like appearance. General formula C2BnHn plus 4. Example C2B4H8, which is the one corner of triangular polyhedra is removed and it is looks like nest. Then arachnocarbonates, two corners of triangulated polyhedra is removed. This is the one corner and another one corner removed. General formula C2BnHn plus 6. Example C2B7H13 and other two carbonates are hypocarbonates and conjunctocarbonates. Then next comes to Watt's rule. This rule provides electron counting rule useful for predicting the structure of boranes and carbonates. First, counts borane. First, count boranes, that is denoted as N. Then count hydrogen. Then, if charge is there, count as hydrogen. One negative charge is equal with one hydrogen. Then find excess of hydrogen. The formula is N is equal to H minus N. That is N to N plus N. And finally predict N plus N. If other atoms are present, like carbon, nitrogen, oxygen, etc., then the table is here. Elements equivalent for boron group equivalent with B boron. For carbon group equivalent with BH. For nitrogen group equivalent with BH2. For oxygen group equivalent with BH3. And the structure and hydrogen atoms, Kojo N plus 2, Nido N plus 4, etc. N is equal to number of boranes, M is equal to number of excess hydrogen, where formula is M is equal to total hydrogen minus N, that is N is equal to number of boranes. For example, C2B7H11, C2 for carbon group equal with BH, equal with BH. So we put BH in place of carbon, BH whole to B7H11 is equal with B9H13, where N is equal to 9, hence number of boron is equal to 9, total hydrogen is equal to 13, then excess hydrogen N is equal to total hydrogen minus number of boron is, is equal 13 minus N is equal to 4, then hydrogen equal with N plus M is equal N plus 4. For N plus 4, the structure is Nido. For N plus 4, the structure of carbon is nitrocarbon. This is the process how to calculate the structure of carbon. Applications of boranes and carbonates. Some applications of boranes and carbonates are there. Boranes are used as rocket fuels in supersonic airplanes, used as catalyst in polymerization reaction, used as reducing agent in organic reactions. Boranes can be used as vulcanizing agent for natural and synthetic rubber. Carbonates are used in cancer drug development. This is the applications of boranes and carbonates. Next, boranes are colorless and gaseous at room temperatures. Boranes are highly reactive and reacts violently with water. In boranes, three-centered two-electron bonds are present. It is unique type of bond. present in boranes only. Carboranes are mixed hydrides of boron and carbon and have some same structure like boranes. Then carboranes derived from pyrolysis of boranes. This is the conclusion of boranes and carboranes. Thank you.